Hello and welcome to Cycle 2 Week 4. You're over halfway through our first quarter, so good job on that. Today we're doing two experiments, number 11 and number 12. Number 11 is called On the Move, and this is talking about inertia. And the question is to determine, or to make it a question, you could say, why do planets continue moving? If they're in space just floating around, why do they continue to rotate and move? Why don't they just stop? Like a toy or something would eventually stop spinning. Why don't they just stop? Would they fall out of space if they stopped? What would happen? Why did God create it like that? What forces did He create? Get some research. What do they know about the planets and why they move? Show them some pictures of planets, and to give them just a little background information. Then for your experiment, after they've done their hypotheses on why they think planets keep moving, you're going to get your materials. You'll have a piece of construction paper, a big one like this, a cake pan, a pencil, and a bag of marbles. You'll each just have one marble because both of these are going to be done as a tutor demonstration. And then for this one in particular, number 11, you could have the kids each have a turn flipping the marble and seeing what happens. The next one I'll leave to your discretion, but may just be a tutor demo for safety reasons. All right, so for this, you're going to just trace the bottom of the pan. You want a perfect little circle, and then you're going to cut it out. Actually, my scissors here. Each of you have scissors in your bin. And as you're doing this, you could begin to put the idea of motion and questions about motion in your kids' minds. Some of the older kids, you might ask them, have you ever heard of Newton and Newton's laws of motions? What do you remember about Newton's laws of motions? Does anything stick out in your mind about that? And see if they have. For this experiment, so I've cut out my circle that fits right in my pan, and I'm going to take a marble, put it in there, and you're just going to come over, whoops, something like that. You're going to roll it so it goes around. The thing says to flick it. That works too, kind of. But basically, you just want to go around. It goes around about once or twice and then just kind of stops. Now I'm going to take out my piece of paper and try it again. As you can observe and see, if I just flick it, it moves very easy. So why is that? What do they think? This is the power of inertia. Inertia, correct definition, would be the resistance that objects have to any change of motion. So we think back to one of Newton's law of motions. Objects at rest tend to remain at rest. Where objects in motion tend to remain in motion in a straight line at a constant speed until an outside force acts against it. You proud of me for remembering that? So that's what's happening here. The law of motion and the law of inertia. For your bigger kids, you could dive into that more. Where else do we see inertia happening? Where in our everyday life do we see that happening? You can even think of a car. It's going to keep moving until we hit the brakes and cause it to stop. If you think about rolling down a hill, you're going to keep rolling until the hill stops and you stop. So that's the power of inertia for that. So number 12 is speedy. Now this talks about also about the planets and their movement. The question here is to determine the effect of distance on the speed at which planets turn or spin. So another way to word that would be, why does scientists have found that the planets far away from the sun orbit at a different speed than the planets close to the sun. Why is that? What do you know about the planets and how they orbit and where they orbit? What are your hypotheses on how you think distance from the sun will affect the speed at which a planet rotates? For this experiment, we have a washer on the string or on the yard of string. It has already been cut and attached for you. Just make sure that your washer is securely put on there so it does not go flying anywhere. All right, follow me. For the first step, you're going to hold it by the end and you're going to get it spinning. You need lots of room for this. So once I get it going, it moves kind of slow, but it makes a nice big circle. All right, then step 2, you're going to move about halfway down the rope and you're going to do the same thing again. And you can hopefully see that this is going a little bit faster. And then last but not least, you get about 10 inches from the washer and then you spin it. And you can see clearly that that spins much faster. So again, you're not going to do all the dialogue I'm doing here. You're going to say, what do you notice? What did you see? Now let's look again when I go farther away. Imagine if my hand were the sun and this washer were a planet. Watch what happens when I go farther away from the sun. Does the planet move faster or slower? And again, what if I'm way far away from the sun? Here's my planet, here's the sun. Does it move faster or slower than the planet that's closer to the sun? Now obviously, planets are not attached to the sun with a cord, but it gives you the idea and a visual on how distance can affect speed when it's talking about planets. And then you can go into that a little bit more. Nicole Liam has some information, and this does too, talking about gravity. The first one talking about friction. So I find with these, going through our scientific method and the research part, giving them some background information, even some basics on friction and gravity and inertia. Giving them some background information will help these experiments make more sense and maybe cause a little more awe factor or wow factor.